Welcome to Mulanga Tutoring session. I hope you're having a wonderful day. This is for grade 12 learners. Um, it's a topic called momentum and impulse. This is what we're going to cover on this video. So click the like button and subscribe also for more videos. So as we are, this is an introduction to momentum. The way I want to introduce momentum, it is through the formula of momentum. So here we go. Momentum, right? The formula for momentum is what? It's P equal to mv. So obviously P is going to be our momentum, right? And then M is going to be our what? Our mass, right? And then V is velocity, right? So here, with the knowledge of what P represent, M represent, and V represent, now we understand what mass is a scalar quantity, and velocity, actually, yeah, mass is a scalar quantity, and velocity is a what? Is a vector quantity. So it means what P is made out of what? Of scalar multiplied by what? By vector, right? Which is going to be what? A vector. It basically means that this momentum that we're going to calculate or we're going to learn about, it is what? Magnitude and what? And direction, right? So with magnitude and direction, right? When we say something has magnitude and direction, it's definitely a vector. But what can those direction be? Normally, we assume that left is what? Is negative, right? And then your right is what? Is positive, right? Up is what? Is positive. And then down is what? Is negative. And this is going to apply for a lot of, for actually all of them, all of the topics in physics, right? You have to know the direction. It's either in terms of left, right, up, down, or north, south, east, west, right? So now, what I want to talk about is the units that are used here. P, we said is momentum, right? We said P is momentum, right? P is momentum. So the unit for P is going to be what? We're gonna get back to that. Let's start with what? With mass. Mass, you have to make sure that whenever you are calculating, your mass is in kg. If it's in grams or given in other unit, convert it to what? To kg. Do not forget. V equal to what? Velocity. And we know that velocity is in terms of meters per second. What then now is the unit for momentum? It's basically kg, meters per second. You get me? These are the units. All right. SI units for momentum. Right? So now let's take it from here. What are we going to do now? An example, right? Let's just give an example, a nice example. We're gonna draw the example. Let's say we have a block, right? And this block is moving on a frictionless surface. This block is 6 kg, right? And it's moving with a velocity of 10 meters per second, right? Remember, no friction, right? So we said momentum is P equal to mv, right? Our mass is 6, our velocity is 10, which gives us what? But here, I forgot something, which is the direction, right? The direction of what? Of the block. We said normally we assume that the left side is what is negative and the right side is what is positive. So here now, because we are not given whether if it's left or right or whatever, we can use whatever that we're using. It's either north, left, right, north, east or left, whatever you want to choose. So you have the freedom to choose here. But because we said left is what is negative, it means our velocity, because it's a vector and it has direction, that's where we put the negative, right? It's a vector. That's where we put the negative. So we're going to have the answer of uh, minus 60. But this is how you write the final answer. You don't write the final answer with what? With a negative sign, right? So you're going to say 60, don't forget the SI units, kg, meters per second, right? Direction, left, because of the negative. Now, it can, let's do an example where now the block is going to the right, right? Actually, no, I'm leaving that to you. Try an example where you are using the formula for momentum and then the block is moving to the right at a certain speed and at a certain mass. So, what have we learned from momentum? Momentum, right? The formula for momentum is P equal to mv. It means that momentum is what? Is the product of what? Of mass, which is m, right? In kgs, don't forget, and velocity, right? Which is in v. And what else can we say about momentum? Momentum is basically mass in motion, right? That is momentum. Thank you. Now we are going to do impulse. Before we do any example from easy, medium, and hard, or even complex, I want us to start by introducing the topic, which is momentum and impulse, so that we can do those examples which are all combined in one, in preparation, obviously, for the tests that are coming and obviously the exams. You can always come to this video and reference and remind yourself. This is an easy topic, guys. So let's go to impulse now. So impulse, right? Impulse. As we did with momentum, we are going to use formulas. We are going to use formulas to introduce impulse. So impulse, I stands for impulse. In some topics, I also stand for initial, but here we are going to use I as what? As impulse. Impulse is what? Is force multiplied by what? By time. So basically, impulse is what? Is force applied at a certain time, right? That is momentum. And force, we know that force is in Newton. right? And we know that time is in seconds. So this is the SI unit for impulse is basically NS, Newton times what? Times time times seconds, which represents time. So let's continue. Uh, Momentum. When we introduce impulse, right? We cannot help but introduce something called momentum impulse theorem, which says I the momentum impulse theorem says I equal to change in P, right? We're going to get deeper into that as we do our examples and questions and on what is change in P, what is change in time, and all those things. So, but for information, for just a bit of information, when we say something is changing, right, it means that it has a initial point and a final point. So when we say change in P, it basically means that we are dealing with different types of different two momentums uh, at a certain point. The momentum at the initial point and the momentum at the final point of the same what object. Don't forget that. So if we are playing around with this with this a formula, we already know that impulse is equal to what? F. So we are changing impulse to F times T, right? Which is going to give us delta P, right? So now we know that NS, this is NS, and this is kg meters per second. So basically, whenever you find these units written like this, just know that it's the same thing. You can either change it to be ns or kg ms as you want without changing anything, right? So you just know that this formula, this they give us the same thing, right? These units are the same basically. So don't forget that as we go on. As we're still playing with the formulas, we want to make f subject to the formula, right? Which is f, this subject to the formula, of course. We want to make f subject to the formula. Let's not forget, let's just mark this. We want to make this subject to the formula, right? I mean the f, sorry, the f subject to the formula. So how do we make f subject to the formula then? We make f subject to the formula by dividing the time, right? We divide the time both sides. You know what you do on the left hand side, you have to do at the right hand side. So f, now we are going to be we are going to be left with what? With f on this side, right? So we have to make sure that we make f subject the formula. Let's just rewrite it down first. So we're basically going to divide by time, right? Yes, and now we are left with f equal to change in p over change in t. So now here is the thing, we can also define force in this manner. We know that with Newton's second law, we define force as F equal to ma. But we can also define force as this, depending on the things that you're given, depending on the I mean, what do you call them? Uh, the units that you're given, or let me say, uh, the things that you're given that you have to deal with. It's either force, are you given momentum, are you given time, are you given all those things, are you given acceleration and all that. The variables that you are given, sorry, yeah, that's the right way. So depending on what variables you are given, you can define force. But if you have momentum and time, you can find the force according to Newton's second law as well. So Let me show you why I'm saying that. So from here, F equal to, we can change this further, right? We can take this further and say F, we know that momentum, right? It's mass multiplied by what? Change in V. Why? Mass stays the same, but the velocity is the one which changes. So we can basically break down change in momentum into M change in V and then delta T. So I'm sure you are beginning to see something that is familiar, right? Uh, so if we break it any further, it's going to be like M multiplied by what? We know that change in velocity, right? Change in velocity over change in time is basically what? Acceleration. You see? MA. So that's impulse. Now, since I've introduced you to formulas, which is P, the first formula that we did, it was, do not forget, let's do a recap. Do not forget, P, sorry, I'm just pressing the wrong buttons. So P equal to what? Equal to MV, right? And then what did we say? We say I equal to what? Equal to change in P. And also I, we know that I can be F equal to Ft equal to change in P. And then what else? The formula that we did, it is, we know that force can be represented as change in P over change in what? Change in T, or MA, right? Are we still together? I hope we are. So now let's just do an example, right? So this is the example, right? From this example, we have a 20 kilograms block, right? And we have a force that is applied on this block, which is 200 newtons. And this block, this force is applied for what? For 10 seconds, right? So now, what I want us to do is to calculate, using the information that we're given, is to calculate the impulse, change in momentum, uh, the momentum, final momentum of the block, and then the final velocity of the block, right? So now let's start with the impulse. What did we say impulse is, right? Impulse, we said impulse is equal to what? Force multiplied by what? By change in time, right? Which basically mean now, like, okay, whenever you approach this questions, make sure that you imagine, you use your imagination, you see these things, and you look at the, so make sure that you use your imagination, right? What am I saying by using imagination? In terms of the formulas, in terms of the block moving and everything, we'll get into that as when we do more questions. Let's say you are given a scenario or you are given a system. Use your imagination to imagine and remember the formulas. I encourage you to know the formulas instead of using the formula sheet. This way you will get to know, and when you approach, let's say, exams, you won't even have to study some of the things because you already know those things. You understand? So now we are given force and time, and we know that we have the formula for impulse, which we can use. We have the formula of impulse, which is force and time. This is the perfect formula for what we are given because we're supposed to calculate impulse. So now, impulse, we have the force of 200, right? And then the time of what? Of 10 seconds, right? Which is basically going to be, what do you call it? It's going to be 2000 NS, right? We agree with that. So that's your impulse. But I want you to notice something. When we talk about force, right? Force is a vector quantity. And this force is applied in a certain direction, right? This force is applied in a certain direction, which is this direction. So we said to the left or to what? To the right. But mostly in impulse, doesn't matter. But when you're going to calculate momentum, uh, make sure that you mention the direction. But for in case, let's just mention the direction of the impulse, right? So it's going to be yeah, right, right. So okay, fine. Now let's go to the second question, which is what? Which is change in what? Change in momentum. With a change in momentum, right? Second, which is change in momentum, right? We are required to calculate that. So we said impulse equal to what? Change in what? In momentum. So we basically have the answer already because impulse is what? Oh, sorry. Because we found that impulse is what? Is 2000, sorry, newtons per second, right? So this is our basically change in momentum. Don't forget, right? Ne? Don't forget, right? So, third question. What is our third question? Our third question is PF, right? So, our PF is basically like the final momentum, right? So, now, here's the thing. We are going to do number 3, right? Which is our momentum final, right? Uh, so, this is going to be like this change in P final minus PI. This is how you write change in momentum in simple form. We minus, right? So remember though, when we are dealing with, okay, let's substitute. We know that change in P is 2000, right? So, as we're saying, 2000, that's our change in momentum, and then equal to PF, that's what we're looking for. So now, and our PI will be 0. Why? Because we assume that the initial condition, the initial momentum is 0. Why? Because the initial velocity is 0 as well. You will see it also when we do the next question. So our initial as momentum is 0 because our initial velocity is 0. Actually, something that is not moving doesn't have momentum. So we assume that basically the moment that we are dealing with is the moment before the force is applied, where time is 0 and the block is at rest, right? So hence the what? The 0. So now from here, let's get our P, right? Therefore, our PF would be what? 2000 kg. Don't forget the SI units. Don't forget the SI units. Uh, sorry. Don't forget the SI units, which is kg, uh, ms, right? So now let's go do the last uh, example on this video, and then from here we're going to do examples from question papers. So number four is going to be our we have to get our VF, right? So which formula can we use? Which formula can we use? Just guess. Just guess the formula that we're going to use in order for us to be able to get our VF. There was a certain formula, right? When we're doing impulse, we said that F is equal to change in what? Change in P over what? Change in what? In T. You remember that formula, right? Or we even don't even have to use this one. We can just say impulse equal to change in P, right? Where we know that our impulse is the same as M multiplied by what? Change in V, right? If we go back to our question, we'll see that our mass is 20, right? Our mass is 20. We never got to use this as much as we should have used. Our mass is what? Is 20, right? So let's go. Let us go. Let us go. So our mass is 20. So we say mass is 20 because we are calculating our change in V. So we know that this one is what? This one is 2000, right? Our impulse, our mass is 20. Don't forget the direction, the signs, they matter. I'm using with the positive sign because it's going to the right. So change in V, which is basically going to give us 20. So change in V is going to be 10, right? Do you agree? Not 10, 100, right? So now we know that our what do you call it? Our change in V will be VF minus VI, right? So it's going to be 100. We said our VI, because the object is not moving at rest, is going to be 0. So basically our VF is going to be what? Therefore, we say, therefore, our VF is going to be 100. Don't forget the units, SI units, right? That's our VF, and that's our answer. But because it's positive, the answer is positive, we say what? Right. Because we assume that the direction to the right is what? Is positive. So guys, thank you for watching and staying this long as we do examples. And please subscribe. I'll be dropping more videos where we're doing more examples from question papers, where we're going to brainstorm and see how they can trick us in some of the questions and how we can approach it, and basically get to know this thing, not cram it, because it's going to also save your time by knowing when you're studying for your final exam, because there are some topics where you don't even have to go revisit, like this one. So stay with me as we explore more on physics grade 12. Also, I'm going to also drop other videos on chemistry as comes by, but for now we are still dealing with physics. So watch out for more videos on my YouTube channel. Thank you. Peace.